What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at Lesson 4.7, Day 2, still angle relationships, but our main focus is parallel lines and perpendicular lines, and we're going to be able to figure out missing angles and determine their relationships. The first thing we want to talk about are what are parallel lines. These are lines on the same plane that never intersect. So in order to do that, they are going to look like a set of railroad tracks, where they're never going to intersect. Perpendicular lines are in the same planes, and they do intersect, and they will always intersect at 90 degrees. So to show a perpendicular line, you just need to make sure that you are showing a 90-degree angle in one of the corners. The final piece of information we're going to talk about today is a transversal, and that's a line that intersects two or more lines. So if we have two lines, like two parallel lines, the transversal is the one that intersects it, okay? These happen to be parallel. You can show parallel lines with two little arrows like this, kind of colored in. That's just showing that they're parallel. The transversal is just going to go through them. So what we're going to do is identify parallel lines, transversals, and how many angles are formed by the transversal. The parallel lines are the two lines that don't intersect at all. So those are lines K and L. L is in the shape, or L is written as a cursive L because a printed L would just look like the number 1. So in math class, your L's are always going to be in cursive. The transversal is the one that intersects it, so that's going to be line M. And then it says how many angles are formed by the transversal. Well, we can see that we have a clear number, 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 angles being formed by the transversal. Okay. What we're going to talk about now are the type of angles that you can have when you have a transversal. The first set we're going to talk about is corresponding angles, and these are angles formed by parallel lines and a transversal that are sitting in the same spot. So for example, I'm going to say this angle right here, we can call this heart angle, also corresponds to the heart angle down here. Or this angle right here could be triangle, which would also correspond here. Notice it's triangles in the top left corner of each set. Maybe we have something down here. We'll call this a square corner. And typically we don't do this with shapes, but sometimes it's easier on the eyes just to understand how they're corresponding. And then a final shape, maybe we just have a circle. This angle will match this one. They're corresponding. Another thing we also want to understand is they are also congruent. That just means they are the same angle measurement. What we're going to do now is use the figures to find the value of the missing angles. And we're going to talk about kind of what we talked about from yesterday, continuing on into this. So yesterday we mentioned complementary and supplementary angles as well as vertical ones. And now we're going to implement the things that we're learning right now. The first thing we talked about yesterday was we know that supplementary angles equal 180 degrees, and that's just meaning we're going to see a straight line. And I actually do see a straight line right here for angles 1 and 2. So we're going to use that 180 degrees here in just a minute. The other thing we want to mention is we just learned corresponding. So if you see this 110 degrees, this is also the matching set for angle 1. So angle 1 is also equal to 110 degrees because they're corresponding angles. They're in the same position, just in different locations of the transversal. To find angle 2, notice that angle 1 plus angle 2 is making a straight line, which is equal to 180. So what I could do is plug in what I have for angle 1 and solve for the missing length, or solving for x. All I would do is subtract 110 from both sides of my equation. So x is equal to 70. So angle 2 is 70 degrees. Next up, we have a similar one. Why don't you take time now and pause this video here, see if you can try what we just did from before. When you're ready to check it, go ahead and click play. All right, the first thing I'm going to determine is, do I have any corresponding angles? Those are usually the easiest ones because there's no math involved there. I do have a corresponding angle. Angle 1 corresponds with 63 degrees. The next thing I notice is that angle 1 is adjacent to angle number 2. These are making a straight line. They're right next to one another, they're making a straight line. So what I can do is I can say x plus 63 is equal to that straight line degrees of 180. I'm going to subtract 63 from both sides to figure out how much x would be equal to. If you were doing this by hand, you did have to borrow. Luckily, it's not too much. 180 minus, oops, I didn't have to reborrow that. 180 minus 63 is going to be 7, 1, and another 1. So we should get 117 for that missing angle. So angle 2, 117 degrees. Okay. Next up is we have a lot of angles here. So again, start by trying to find corresponding angles first. You are going to have to think outside the box here. Maybe think about some vertical angles. And then last but not least, we can talk about some supplementary. Okay, maybe take a moment first, see what you think about these, and then click play when you're ready to check your answer. All right, 75, I looked for all corresponding angles, and right now I only seen one corresponding angle, and that's angle 6. So angle 6 corresponds with 75 degrees. The next thing I have to ask you to look for is vertical angles. Remember, vertical angles are opposite from one another, but still equal. So opposite meanings, if I have 75 here, the opposite angle from that is angle 1. So angle 1 is also 75 degrees. Do you see another vertical angle? The other vertical angle we have is angle 4 from angle 6. Both of those are going to be 75 degrees. Or you can just say if angle 1 is 75 degrees, angle 4 corresponds with angle 1. So 4 would also have to be 75 degrees. The last few that are left over, we know that they can have the relationship of supplementary. Take, for instance, angle 2 and 75 degrees. Notice how they're making a straight line. So what I can do is set x plus 75 degrees equal to 180, and then solve for x by subtracting 75. When I subtract 180 from, or 75 from 180, I'm going to get 105. So that means angle 2 is 105 degrees. According to my rules for vertical angles, that means angle 3 would be 105 degrees. Angle 3 corresponds to angle 7. So angle 7 is also 105 degrees. And angle 7 is vertical from angle 5. So angle 5 is also 105 degrees. There are a lot of relationships that we just talked about there, but that would be how you can find all of your missing angles in a transversal with parallel lines. How about you take the time and pause the video here, try this question on your own, and when you're ready to check, click play. All right, the first thing we want to look for are any corresponding angles. Once you find corresponding angles, you can then detail vertical angles. Both of these require no math at all. The final one we can do is maybe look for supplementary, which does require a few mathematical things to do, but not much. Talking about corresponding, 59 corresponds with angle 5, so angle 5 is 59 degrees. Vertical angles, angle 5 is vertical from angle 7, so angle 7 is also 59 degrees. And 59 degrees is opposite from angle 2, so angle 2 is 59 degrees. Okay. The final part is supplementary. If you look here in the top, I have angle 1 and 59 degrees making a straight line. So I know that x, which would be angle 1 plus 59, is equal to 180. To find out what x is, or find out what angle 1 is, I'm going to subtract 59 from both sides, so I get x is equal to 121. So angle 1 is equal to 121. Angle 3 is also 121 because they would be vertical. Angle 4 is corresponding to angle 1, so that means angle 4 is also 121 degrees. And angle 4 is opposite or vertical from angle 6, so angle 6 is also 121 degrees. The final piece of information we will talk about today are alternate interior and alternate exterior angles. Interior angles or alternate interior angles, I forgot the alternate here. Alternate are angles formed by the transversal inside the parallel lines, and exterior angles will be the ones that are formed outside. Okay, so alternate interior We're going to call those AIA and AIA. Okay, these two purples match because they are formed by the transversal and they are inside. We have another AIA set. Both of these are congruent. Alternate exterior angles, which would just mean on the outside of the parallel lines, we have AEA matches AEA. And then last one, here's another set of alternate exterior angles matching those. Okay. So this next piece of information, it says alternate interior angles are congruent and alternate exterior angles that are congruent. What we're going to do is we're going to piece together those things that match. So just like before, I have a 3 and alternating on the inside is 5. So angle 3 is congruent to angle 5. The other set of alternate interior angles is angle 4 and angle 6. Notice I'm using the arcs or the rings inside of the angles, and I'm also trying to color coordinate for you. So angle 4 is an alternate interior angle of angle 6, which means they are congruent. Finally, we have alternate exterior angles. Let's start with angle 8. That's going to get 3 rings. Exterior angle 8 matches with alternate exterior angle 2. They are alternating on the exterior of the transversal. That's essentially what it means. The last two are the ones we haven't touched yet. Angle 1 is going to get 4 arcs matching with angle 7. Those are alternate exteriors as well. Now, that does not mean angle 1 and angle 7 can't be matching with 3 and 5, because if you notice, angle 1 is vertical to angle 3 and angle 5 is vertical to angle 7. So really what I could maybe do is still have these with purple, but they both have 1 ring. And line angle 8 and angle 2 are vertical from angles 4 and angle 6. So that means they can also match, okay? So we're going to talk about one more example, and then it'll be working time in class. In example 4, the measure of angle 4 is 84 degrees. So I'm going to zoom in here. We're going to find the measure of the angle and explain your reasoning. So angle 4, they say, is 84 degrees. So we're going to write in maybe a better color, 84. If angle 4 is 84 degrees, then what would be the other angle measurements? Okay. Right now it has us working on 3 and 6, so we can go ahead and talk about 3 and 6. Angle 3 is right next to angle 4, and again, notice that 3 and 4 are making that supplementary line. So what I could do is do x plus 84 is equal to 180. So I'm just taking my 180 and subtracting 84. When I subtract 84 from both sides, I'm going to get 96. So x is equal to 96. If angle 3 is equal to 96, so is angle 6, because these are alternate exterior angles. So 96 degrees. Okay. Notice where 2 and 7 are. 2 is exactly opposite from 3, and that means they're vertical. So 2 would also be 96 degrees, and 7 would be 96 degrees because 2 and 7 are alternate interior angles. They are alternating on the inside of your transversal, so they're still going to be at 96 degrees. So now we've got our fill in the blank things. Angle 3 is 96 degrees. Angle 5 we haven't accomplished yet, but if you notice, angle 4 and angle 5 are alternate interior angles. So if angle 4 is 84 degrees, so is angle 5. Angle 6 we've already discussed is 96 degrees. The only two we didn't get a chance to fill out were 1 and 8, so we can do those really quickly. Angle 1 would be 84 degrees because it's vertical from 4. And angle 8 is also 84 degrees because it's vertical from 5. But also, angle 1 and angle 8 are considered alternate exterior angles. Okay? That'll be the conclusion of our notes today on day 2 of angle relationships. Hopefully this